Well, in this video, I will introduce sigma notation and limits of finite sums, which is basically the formal definition of a Riemann sum, and a definite integral. So in this video, you will solve limit problems by taking a function and express it as a limit of a sequence of a Riemann sums over an interval. So I like to call this the long way of finding the limit. So segmentation and finite sum, uh, it could also be written as this. This is the segmentation, and the I represents your starting point, and then your ends represents your ending point, where I is the index of summation and AI is the ith term of the sum. AI is the ith term of the sum, and the upper and lower bound summation are n and 1 respectively. Okay, so if you look at the first example, evaluate the sum, um, where k is 1 and 5 is 2, and then your nth formula is 2k. So they give us everything we need, the nth formula 2k, and we start from our lower boundary is 1 and then our upper boundary is 5. So what you're going to do is just, so yeah, you're going to do is 2 times 1 plus 2 times second until you get to the fifth term and you add them all up and you get your the sum. Plus 2 times 3 plus 2 times 4 plus 2 times 5. So you know that 2 times 1 is 2, plus 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and then 2 times 5 is 10. And you get 30. Okay, so if you look at 1b, it's the same idea, but the difference is, uh, so you can redo this problem. So we're going to go over the rules later, but the shortcut is, if you have a constant in front of the letter, you could take out that constant and bring it back at the very end. So you can rewrite this as this 2 is a constant, so take it out, and it's going to times it by the summation of k equals 1, and then upper boundary is 5, and you stop at k. So our new nth formula is k, and then we go up to 5. And then we can, once we simplify that, then we can multiply everything by 2. So this is going to be 2 times, so 1 times k is 1, plus, go up to 5, so then it's 2 plus 3 plus 4 plus 5. So what's 1 plus 2 plus 3 plus 4 plus 5? That is 15. So 2 times 5, 15 is 30. Okay, what about 2a? So here's our nth formula, j squared plus 1. We start from the second term and then we stopped at the seventh term. So it's going to be written as, so you start with 2, so it's going to be 2 squared plus 1. That would be your first term. Plus the second term, or the third term is 3 squared plus 1 plus 4 squared plus 1. until you get to the 7. So this would be 5 squared plus 1, 6 squared plus 1, and then this is 7 squared plus 1. So 2 squared is 4 plus 1, 3 squared is 9 plus 1, 4 squared is 16 plus 1, 5 squared is 25 plus 1, 16 squared is 36 plus 1, and plus 7 squared is 49 plus 1. Okay, when you simplify that, that is going to be 5, 10, 17, 26, 37, and 50. And that gives you 145. Okay, what about B? So the shortcut is, if you want to do this again, you can rewrite this as two separate integration. So what I mean is, like, you can rewrite this as, so this B is the same thing as the first problem. It's just that you can break it apart as two separate summation. So you can rewrite this as j equals 2, a 7, and then you have j squared plus, and then this is a constant of 1. We can't just take it out, so what you could do is just write out as its own summation. So j equals 2, and then stop at 7, and then 1. Okay, so let's do the first one right here. So you start at 2, and then you end up to 7. So it's going to be 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared, right? Plus, now let's do the other summation, this one. So it doesn't matter if you start at 2, your output is always going to be 1. So it's going to be, if you start at 2, this spits out a 1. So it's just going to be 1 plus 1 plus 1 until you get to 7th. So 3 plus 1. 7. Okay. So when you put it all together, uh, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, plus what's 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1? That's 6. So that's 145. Okay, so we can go over the rules. And then 3 is it's slightly different. We don't have an nth formula. It's f of x f of x subscript 1 times it by delta x. So this is going to be related to our problem. So what you're going to do is rewrite it as, so we start at 1, your I is 1, and then we start, so it's going to be written as f of So, uh, let's talk about definite integral. So definite integral, if f is a continuous function defined for a of x, a less than equal to x, less than equal to b, and if the interval of a to b is divided into n subintervals of equal width, such that delta x is equal to b minus a over n, and x of I is equal to a plus I of delta x is the right end point of the subinterval of I, then the definite integral of f from a to b is this. So if you look at a curve and you're from a to b, this is exactly what you're doing. Your delta x is the is the width, and then your f of x subscript I is the height. So over here, your height would be f of a, and then your delta x would be uh, delta x. So this all will make sense when we go over the rules. So let's do an example just to make sense of this. So example 4 says, use the definition of the definite integral to express as a limit of finite sum. Do not evaluate. So our integrals is from 3 to 10, and then it's ln of x over x of d of x. So what we have to do is use the definite integral. So first step is find delta x. Okay, so delta x is going to be b minus a over n. So what is that going to be? So this is our a, 3 is our a, and 10 is our b, right? So it's b minus a, so it's 10 minus 3 over n. Okay, so 10 minus 3 is 7 over n. Okay, so that is our delta x. And what I would do next is step 2 is find xi. So xi is a plus I times delta x. Okay, so that's going to be xi equals a. So our a is 3 plus I times delta x. So it's I, and our delta x is 7 over n. So I guess if you want to simplify this, this would be 3 plus the 7 I over n. Okay, step 3, substitute limit as n approaches infinity. Okay, so you're going to write it out as the summation of I equals 1. And we have n, and then it's going to be ln of xi over xi times by delta x. So dx becomes delta x. So what you're going to do is replace x with xi. So I'm basically trying to, we're going to set it up. So we're going to replace x with xi. Okay. Okay, so what it's going to look like, it's going to look like this. So as a limit, as n approaches infinity, times the summation of I equals 1 of n, and then you have ln of x, ln of x sub x xi, and we said that xi is 3 plus 7i over n. So it's going to be 3 plus 7i over n over xi. So what is our xi? It is 3 plus 7i over n times this by delta x. So delta x times it by delta x, and our delta x is 7 over n. Okay. Then we're just going to leave it like this because it says do not solve. But we'll go over the rules. What we could do is use the rules to actually solve it and get an actual value. So this is just how you set it up um, by using the definition of the integral, definition of the definite integral. And this is the definition of definite integral. So go ahead and write this down if you need to. Right here. Okay, let's do another example. So example 5, same directions, use the definition of the definite integral to express as a limit of finite sum. Do not evaluate. So step 1, so we have the integral from 1 to 4. So 1 is our a, and b is our 4, right? And step 1 is first I'm going to find my delta x. So my delta x is b minus a over n. So my b is 4 minus a, which is 1 over n. So 4 minus 1 is 3 over n. Okay. And then step 2 is find xi. So xi is a plus I times delta x. So my a value is 1, and then it's I times delta x. So it's I times delta x, and my delta x is 3 over n. So simplify that, that's going to be 1 plus 3i over n. Okay. Step 3, set it up. So it's going to be the limit as n approaches infinity of I equals 1 of n. And then what we're going to do is replace x with xi, right? So you're going to replace x with xi. So this would be, if you look at our original, we have x squared plus 2x minus 5. You're going to replace x with xi. Yes, so replace, let me write this down. So you're going to replace x with xi. So this is an x, this is an x. So wherever you see an x, replace it with xi. So this would be xi squared plus 2 times xi minus 5. And then we have to replace dx with delta x, right? Replace dx with delta x. So if you kind of clean it up, this is going to be the limit and then I'm going to just infinity. I plus 1 of n. Then this is going to be, now you replace xi with 1 plus 3i over n, right? And then replace delta x with 3 over n. And then that's it. You could FOIL this out, 1 plus 3 in, but I'm just going to leave it like this because it says do not solve. Okay, so now we got to, the next step is we're going to solve the actual summation. So this is why we need to go over the summation formulas. So go ahead and write these down. So because we will use these later on when we do more of the examples. So the first one is summation of I goes to n of c equals this. So basically, if you have a constant, you can pull that out in front of the summation, right? And then it's going to be equal to this. So pull it out, and you get this. I equals I of n of 1 equals c of n. Okay, step 2. So if you have something like this, n times n plus 1 over 2, it can be written as n squared plus n over 2. Okay. Okay, rule 3. If you have an I square anywhere in your summation, it can be expressed as n times n plus 1 times 2n minus 1 all over 6. Or it could be simplified as 2n cubed plus 3n squared plus n all over 6. Okay, so if you have an I square like here, it would be expressed as this. Okay, rule 4, if you have an I cube anywhere in your summation, in your nth formula, it would be expressed as n squared times n plus 1 squared all over 4, which can be simplified as n fourth plus 2n cubed plus n squared all over 4. Okay. And if you have two separate summation, you could break it down into 2 different summations, right? Like, so what I mean is like, let's say you had like 3x squared plus 4x plus 1, right? You have 3 different ones. You could just break it down into 3 different summation. Okay, so if you need to go back to the rules, go ahead and go rewind because we're going to use it to the next example. So example 6 through 8, use the definition of definite integral to evaluate, for example, 6 to 8. So we want an actual value. So let's look at example 6. example 6. So our lower boundary is from 0 and our upper boundary is 4. So our a is 0 and my b is 4, right? And here's our nth formula, x cubed minus 3x times dx. So what's the first step is find your delta x. So delta x is b minus a over n, and our b is our upper boundary is 4 minus our lower boundary, which is 0 over n. So 4 minus 0 is 4 over n. Okay. Second step I would do is find xi. So it's basically a plus I times delta x, which is going to be our a value is 0, our lower boundary is 0, plus I times my delta x, and my delta x is 4 over n, which is going to be 4 I over n. Okay, then what you have to do is step 3. So remember, you have to replace, in step 3, we're going to write out the summation. So just replace x with xi, and then dx will be your delta x. Okay, so you see this dx is going to be a delta x, and then you're going to replace anything within x, you're going to replace it with xi. So step 3 is kind of write it out. So the limit as n approaches infinity of I equals 1 times n. So if you go back to our formula, is x cubed minus 3x. So my x is 4 I over n squared minus 3 times my x is 4I over n times it by delta x, and my delta x is 4 for n. Okay. Okay, so now we have to do some algebra. So we have to like FOIL it out. So I know it's a pain. You have to write out it again, limit as n approaches infinity of this summation. So 4I over n squared, that is going to be 16I squared over n squared. Okay, so all I did was I squared this, right? What's 4I squared? 16I squared. What's n squared? N squared. And then FOIL out this negative 3, so this is going to be negative 12I over n times it by 4 over n. Okay, and then you're going to have to FOIL this out. So visually just FOIL 4 over n by 16I squared over n squared. So let me write this out. So it's going to be the limit as n approaches infinity of I equals 1 of n. Okay, so yeah, what's 16I squared over n squared? If you FOIL this out, this is going to be 16I squared times 4 is 64. So 16I squared times 4, so I'm like FOILing this out, right? That would be 64I squared, and then n squared times n is n cubed, minus, and then let's multiply this by 4 over n. So what's negative 12I times 4? That's negative 48I over n squared. Okay. You can also you can sum up the first minus the sum of the second. Okay, so this is where we come to our rules. So see how we have two terms, this term and this term. So what you could do is just write it out as two different summation, right? Because that was part of our rules. If you have, you can write it out as you can either write it out as two different or two addition summation. I'm gonna write it out as two different summations. So this is going to be 64 I square over n cubed minus the limit as n approaches infinity. Okay. Then we have to use our rules. So on this one right here, we have on this summation, right? You have a constant of 64. So according to the rule, you can take out that constant, put it in front of the limit, and also n cubed is also a constant because if you put, let's say n was 1 or n was 2, it's still a constant, right? 1 cube is 1, 2 cube is 8. 8 is a constant, 1 is a constant, so you could take that out. So 64 in n cube, I could just take it out because it's a constant, so you can rewrite this as the limit as n approaches infinity, and then take out the constant 64 in n cubed. I equals 1. And the same thing here, the 48 over n squared, that's a constant because if n was 1, 1 square is a constant. If n was 2, 2 squares 4, which is a constant. So go and take that out. Okay, and then what we're going to do is use our rules. So according to the rules, I square is going to equal to 2n cubed plus 3n squared plus n all over 6, right? So if you scroll back to your rules, I square is going to be 2n cubed plus 3n squared plus n all over 6. So that's what you're going to do. You're going to replace that with that. So it's going to be the limit as n approaches infinity of 64 over n cubed. And then you're going to replace this whole thing right here as 2n cubed plus 3n squared plus n all over 6. What about here? According to the rule, if you have an I, it simplifies as n squared plus n over 2. So you can write this as minus the limit as n approaches infinity, 48 over n squared. And then you're going to replace this whole thing right here with, oh, it's actually n squared plus n over 2. Oh, that's what I just said. Okay, and then go ahead and simplify. Okay. So you see 6 is a constant. If you take that out, that's like 64 over 6, which becomes 32, right? 64 divided by 6 is definitely, oh no, it just can be reduced, right? 64 over 6 can be reduced by at least 2. So that would be 32 over 3. So that's what I'm going to do. I'm just simply going to reduce this to, this will be 32, and then this will be 3. So it's going to be 32 over n cubed times 2n cubed plus 3n squared plus n all over 3 minus the limit as n approaches infinity. And then the same thing with 48 over 2. That I think that comes out, does that come out nicely? Yes, it's just 24. So it's going to be 24 over n squared times n squared plus n over 1. So it's going to be the limit as n approaches infinity. And then I guess you can just FOIL this out. 32 times this whole thing, and then 3 times n cubed is going to be 64 n cubed plus 96 n squared plus 32 n all over 3 n cubed minus the limit as n approaches infinity is going to be, so over here, just FOIL out this 24, so that would be 24n squared. It's 24n all over 1 times n squared is n squared. So now, how do we solve this? Because our final answer has to be an actual value. So you kind of have to know your horizontal rules, because what is a limit? This is a rational function, right? This is a rational function. And what is the limit of a rational function? It's the horizontal asymptote. So you need to know your HA rules. So this is going to be the limit as n approaches infinity. So you kind of have to look at the highest part and versus the low highest term on the numerator and the highest term on the denominator. So your highest term on the numerator is 64 n cubed over the highest term on the bottom is 3 n cubed, right? So what is the rule? So what is this? This is when the degrees are the same. So when the degrees are the same, what is the horizontal rule? You use the coefficient. It's 64 over 3. Okay. And then minus the limit as n approaches infinity. And then you look at the highest term on the numerator and the highest term on the denominator. So your highest term on the numerator is 4n squared. And then the highest term on the bottom is n squared. So again, the degrees are the same, so you just use the coefficient, so 24 over 1. Okay, so it's going to be 64 over 3 minus 24 over 1. And then just simplify, so your LCD is 3. 24 times 3 is 72. So 64 minus 72 is negative 8 over 3. Okay, so that is your answer for this one. Pretty cool, but it's also pretty tedious. Later on in the next few lectures, you'll see there's an easier way. Uh, okay, so let's move on to example 7. So example 7, we got to find the integrals from 4 to 6 of 2x squared dx. So first step is find your delta x. So my delta x is b minus a over n. In mind, 4 is your a, 6 is your b. So 6 minus 4 over n, just 2 over n. Okay, step 2, find your xi. So xi is going to be a plus I times delta x, which is going to be, what's your a value? 4 plus I times delta x. Delta x is 2 over n. So that's going to be 4 plus 2I over n. And then what you're going to do is replace x with xi, right? So then you're going to start writing it out. The limit ends on infinity. So it's 2, and then we said that replace x with xi, so it's going to be xi squared times it by dx. And would we say we replace dx with uh, delta x? Right? Yes, you replace dx with delta x. What's our delta x is 2 over n. Okay. So guess you can start cleaning this up. So this is the limit as n approaches infinity. Xi squared is x squared I times it by 2 over n. And then that simplifies as xi is 4 plus, xi is 4 plus 2I over n. Times it by 2 over n. And what is 4 plus 2I over n squared? Let's just kind of clean that up. So 4 plus 2I over n squared is 4 plus 2I over n times it by 4 plus 2I over n. And that simplifies as 16 plus 8i over n plus 8i over n plus 4i squared over n squared. And that simplifies as 16 plus 16i over n plus 4i squared over n squared. Okay, I guess now we can rewrite this as the limit as n approaches infinity. It's 2 times, so it's 2 times, so it's 2 times this, so, or times by this thing by 2. So, um, let's see. So it's 2 times this times it by 2 over n, right? So if you do, so 2 times this whole thing times 2 over n, and what happens is you get, uh, it simplifies as 4 over n times 16 plus 16i over n plus 4i squared over n squared. And that simplifies as, so now we have exactly 3 terms. So according to the rule, we can write it out as 3 different summation. Okay, so now we wrote it as 3 different summation. Now we have to use our rules. So let's start with the constant. So remember, we could put the constant in front of the limit. So 64 over n is a constant because n can be like 1 or 2, which is constant. On the second one, you could take out the 64 and the n squared. And then on the third term, you can take out the 16 and the n cube. So that's when I'm going to write it out. So this 16 over n cubed could be written, yeah, that's a constant, so that's 16 over n cubed. And okay, now we have to use our summation rule. So uh, this one can be like an n, right? Right, one is a constant, so you can write that as an n. This I, according to the rule, I can be expressed as n squared plus n over 2. And then this I squared can also would be expressed as, or could be replaced as 2n cubed plus 3n squared plus n all over 6. So what I'm going to do is do that. Okay, so replace I with n. And then replace I with n squared plus n over 2. And then you're going to replace I squared with 2n cubed plus 3n squared plus n all over 6. Okay, and then just FOIL it out. So this was going to be the limit as n approaches infinity of 64n for n plus the limit as n approaches infinity. So when you FOIL 64 over n squared with this, you should get 32n squared plus 32n all over n squared plus the limit as n approaches infinity. And then when you FOIL this out, 16 over n squared is going to be 16 n cubed plus 24 n squared plus 8n over 3n cubed, right? And if you clean this up, what's 64 over n is 64. Or actually, you're using your your horizontal rules, right? So what is the limit as n approaches infinity of 64 over n? Well, see how the degrees are the same? So you just use the coefficient, so that's 64. The same thing here, you pick the highest term on the numerator and the highest term on the denominator. So it's 32 n squared on the top, and then the highest term on the bottom is n squared. So the degrees are the same, so you just use the coefficient. Plus, the highest term on the numerator is 16n squared, and the highest term on the bottom is 3n cubed. So according to your horizontal rules, if it's bottom heavy, it's 0. And actually, I made a mistake. This should be a cubed. So now it's the degrees are the same. So what's the rule? Use the coefficient. So it's 16 over 3. So when you put it all together, you get 304 over 3. Okay. Okay. Last one. So example 8, use the definition of the definite integral to evaluate. So step 1 is find your delta x. So your b is 0 and your a is -2. 0 minus -2 all over n. So that's 2 over n. Step 2 is find xi. So xi is a plus I times delta x, which is -2 plus I times 2 over n. So that's going to be xi equals to -2 plus 2i over n. Okay. Step 3, write it out or start writing it out. So the limit as n approaches infinity, you get I equals 1 and then n. So you're going to replace x with xi, and then you're going to replace delta x with your dx with delta x. Okay, so it's going to be -2. Wait, oh no, it's going to be 3, and then replace x with xi. So this is going to be xi squared plus 2 times xi plus 1 times it by delta x, which is 2 over n. Okay, so this simplifies as, so this part right here, 3 times xi squared, so it's 3 times x. What is our xi? Is that whole thing, -2 plus 2i over n. And then it's 2 times -2 times it by 2 over n. So if you clean this up, -2 plus 2i over n is going to give you 4 minus 4i over n. Wait, actually, when you FOIL this out, it gives you 4 minus 8i over n plus 4i squared over n squared. And basically, if you FOIL this whole thing out, I'm just going to save you time. It's going to give you 18 over n minus 4i over n squared plus 24i squared over n cubed. So when you do all the algebra, FOIL everything out, including the 2 over n, you're going to get this. Okay. So what are we going to do? We have three terms now. We can break it into three different summation. Okay. So 18 over n is a constant. Uh, 40 over n squared is a constant. 24 over n cubed is a constant. So take out the constant. So it's going to be 18 over n n approaches infinity. And then 40 over n squared is a constant. So that's like 40 over n squared. Equals 1 of n I plus the limit as n approaches infinity of 24 over n cubed I equals 1 over n. Okay, and then you need to use your information rules. So this is fine. Uh, over here, we know that I is going to be n squared plus n over 2. And over here, we know that I squared is going to be 2n cubed plus 3n squared plus n all over 6. So let me write that out. Okay, so we said that I can be expressed as n squared plus n over 2 plus the limit and then approaches infinity. And then it's going to be 24 over n cubed. And then we can replace I with 2n cubed plus 3n squared plus n over 6. Okay. So now this simplifies as the limit as n approaches infinity of 18n over n. So if you FOIL this out, this is going to give you 20n squared plus 20n all over n squared plus the limit as n approaches infinity. If you FOIL this out, you're going to get 8n cubed plus 12n squared plus 4n all over n cubed. Okay, so now you got to use your horizontal asymptotes. So on the first one, 18n over n, the degrees are the same, so you use the coefficient. So that's 18 minus, on the top, on this one, the highest term is 20n squared, and the highest term on the bottom is n squared. So it looks like the degrees are the same, so you just use the coefficient. So that would be 20 plus, over here, the highest term is 8n cubed, and then the highest term on the bottom is n cubed. So it looks like the degrees are the same, so you just use the coefficient. So when we put it all together, you should get 6. So this is sigma notation and limits of finite sum. And next video is going to be a bit more easier. It's going to be integration rules, and we'll go over the integration rules, which is so much easier than this and much faster. Okay, so that wraps it up for this video.